Yeah, so if we create a basic 3D plot, turn off those things. Okay, so what we do is we can go to date defines limits is just not the default. We can tell it to auto centralize, so increase that a little bit. As we move through the data, it always tries to centralize and normalize the data size based on the data currently in the extremes. So if we add some nodes, so all I've done there is just literally click on the kmeans to enable the manual, and then click on add nodes, and then holding down shift to move, and then left click to add a node, left click to add a node, left click and left click, finger off the shift button. And because we're on auto normalize centralize, this is what I've done this evening. I've managed to get this working so that as long as the limits don't change too much, like there, it's thrown it a little bit, but it'll automatically calculate where the nodes should be. Yes, I had it so that it would work with the user limits, but then you'd have to keep clicking copy the limits to make it work. But now it works with the normalize and centralize mode. It's just much more flexible now. Obviously, you can use the exclude sphere. This mouse wheel up and down makes it semi-transparent. Control and mouse wheel up here increases its size. And how do I move it? Can I move it? Then we've got to turn off the add modes and shift and just moving the mouse will relocate the exclude sphere, and you see it's automatically calculating the node position based on the data that's not being swallowed up by the exclude sphere. If I make this exclude sphere transparent by adjusting the mouse wheel on there, you can see the data that's within the sphere is grayed out. Okay, so basically the exclude sphere is swallowing data. And then these points here are the mean XYZ position of the data that's allocated to that particular node. We can still use the include spheres, and if you move within here and hold down Control and Alt and mouse wheel up, you can increase the size of them. So this is the data that's allocated to, it's catching up. Now to mouse wheel down, bring it back down again. So the data within each node here is the result of everything minus what's within the exclude sphere, and it's a Boolean operation, and what's within the include sphere, and everything else is grayed out. So if I was to come over here and click this button here, if I left click, it says convert first 9 nodes to marked events. There's 5 nodes, so if I was to click that, then immediately, if I move this aside, all the data is being allocated to various nodes, and not all of it. You can see there's a lot of gaps there, but that's the data that's not within the include and is also within the exclude sphere. It's not included there. So there we have it. So the kmeans works with any data. I can go to anything really, temperature, pressure. So the axes now are acceleration Y smooth, Z smooth versus pressure, and it still works quite happily, which is kind of what we wanted in the long run. So we're just flying through the data, and it's, you know, it's calculating on the fly. So as I say, the data within each of these nodes can just be pushed to the 2D marked event system, and then immediately it's available to the behavioral cascade. So what we need to understand how we can do stats on data that's three-dimensional but consists of various channels: acceleration, pressure, temperature, even magnetometry, VEDBA, VESPA, etc. We just need to know how we can understand the stats, the variance and whatnot. I'll leave it at that. I'll also upload a copy of this to GitHub, so you can access it when you've had enough of the marking.